Today we're going to be discussing the foundations of dealing with functions, and in particular, how we identify functions, how we talk about functions, and what are the most important components of functions, which is the domain and range. As you get deeper in math, you're going to be seeing functions and function notation all the time, and in particular, the course College Algebra and Pre-Calculus are both at their core the study of functions, and also other math classes beyond them are as well. But it's really key part of mathematics. So let's get our notation and our vocabulary here straight. Anything is a relation if it somehow compares x and y or some input and output. So any sort of relation takes some set of inputs and relates them to some sort of outputs. So it can even be something as similar as the input of you want a cheeseburger and the output that will cost you $3. Bada boom, that's a relation. So it's anything where you put in an input, it takes out an output. A relation is specifically a function if every x in the domain has exactly one value of y in the range. So let's break that down a little bit. So in particular, on a standard function, you take elements of the domain, aka your input, and map them to elements of the range, aka your output. So if it's the case that a cheeseburger is only going to map to $3 no matter what, that's a function. However, if a cheeseburger can cost either $3 or $5, suddenly it's not a function. If I give you that I want a cheeseburger, I don't know how much I'm going to be spending. So that would make it not a function. We're going to go into more detail here, but you want to be thinking domain comes first in the alphabet before range. So domain is your input. It's what you input. It's what you set to give you the output as the range. A way that you very kind of can quickly check from a set of order pairs is that there should only be one x listed each time. So each x only goes to one y is another way this is often said. Each x goes to one y. And we'll see some more examples here. Recall also that means that the domain is your set of inputs, most commonly your x's, and the range is your set of outputs, most commonly your y's. I'm going to say x's and y's because if you're talking about like an actual graph on the coordinate plane, that's what it's going to be corresponding to, but technically the concept of a function is a bit broader than that. Now we talked quite a bit about this idea that function is defined as each input having one output. So let's sort of see some practicality of that. So for example, if your inputs were P, Q, and R, if P goes to M, Q goes to N, R goes to N, that is considered a function. There is no input that goes to more than one output. Notice that it's okay that both Q and R go to N. In our fast food example, that would be that both a cheeseburger and some chicken nuggets both cost $3. That's fine. It's still the case that if I tell you I want chicken nuggets, I know I'm only going to pay $3. And if I want a cheeseburger, I'm only going to pay $3. If I go up there, I say I want chicken nuggets, and you're like, could cost these 5 different things, I'm going to be mad because that's not a function. It should be that when you put in an input, there's exactly one output. And it does sometimes work out that each input has a unique output too. That's great. So only one item on the menu costs $3. Cool. But what's not okay is an input mapping to more than one output. So this in particular is the problem. This makes it not a function. So that's really what you're checking here when you're checking if something's a function. You want to check that you're not in this last situation where you're going to have an input that maps to more than one output. Now let's see more of the format that you're probably going to see in a math class. So here we have a set of functions, or a function that's just a set of points. So let's list the elements of the domain and map them to the elements of the range. So the domain, those are going to be all of your x values. Your x values are considered your inputs. So in particular here, I'm going to list that my elements of the domain are -3, 6, and -4, and it looks like -4 is listed twice. For my range, those are going to be all my outputs, aka my y's, so that'll be -3, -9, 6, and 1. So that's what I'm going to list for my range here. We've got -3, -9, 6, and 1. And if I'm mapping how these are related, -3 goes to -3, cool. -6 goes to -9, cool. But -4, he goes both to -6 and 1. This is my problem if I'm going to try to determine if this is a function. This is a problem because there is an element of the domain that maps to more than one element of the range. This means it is ultimately not a function for exactly that reason that we just listed. Go ahead and try the same process with the next set of points. So list off the domain, list off the range, and then determine if the relation is a function. So let's do the same process here. We're going to list off the domain, list off the range, and I'm going to kind of list them at the same time this time and sort of how they map. So in particular, for the first point, -3 is the element of the domain that maps to 8 in the range. Then we have -2 in the domain, mapping to 3 in the range. Then we have 0 in the domain, mapping to -1 in the range. Then we have 2 in the domain, mapping also to 3 in the range. I noticed that I already listed 3, so we can go ahead and show that both of them go to 3. That's fine. Then we have 4 in the domain, mapping to 15 in the range. So in this case, is it a function? It is. It's okay that both -2 and 2 go to 3. What would be a problem is if -2 went to both 3 and -1. So we're okay. And how would we justify that? We would say yes, it is a function, and then we'd basically repeat the definition of the function. Every element in the domain maps to exactly one element in the range. Now it's possible when you're listing the domain and range, you may want to be a little bit more proper about it and actually list each element kind of from least to greatest in the order of the number line. So in particular, for our first problem, the way we'd list this in a little bit more formal set notation is we'd use these little curly braces. We would say -4, -3, and +6 are the elements of the domain listed from smallest to greatest. Notice how I use the curly braces and not a bracket or parenthesis, because if you use a bracket or parenthesis in interval notation, that's going to imply that full range of values, which isn't what you want to imply. For the range, you would similarly list off -9, then -6, then -3, and then 1 from smallest to greatest. And then for the second example, you could do a similar process, but again, you have to list all of them individually because you don't have any of those numbers that are in between. This is just a discrete set of points. So my domain in particular would be -3, -2, 0, 2, and 4. And my range in particular would be -1, 3, 8, and 15, because those are the only numbers that are in this function. We can do a similar sort of process to determine if a set of points is a function. So go ahead and pause your video and see if you can identify which of these are and are not functions. So for this first table, the problem I see, which I'm going to go ahead and sort of relist the points, is we have -5 going to -3, that's great. Then we have 1 going to 2, cool. We've got 4 going to 2, also cool. We've got 7 going to 8, cool. But the problem is then we have 1 also going to 10. And I'm actually going to kind of list that more explicitly. Bada boom, bada boom, bada boom, bada boom. But really, these 1s are repeated, which means 1 also goes to 10. Sort of in practicality, what you're actually searching for is, do I have a repeated x value such that that x value ends up going to 2 different y values? If so, that's not going to be a function. And then sort of same thing in the next table. The next table, it looks like we're good because each of those x values is unique, and they each actually happen to also go to a unique y value, so we're double good. What's the problem in this next table? In the next table, I've got 1 going to 2 different numbers again. That's a problem. So that would not be a function. And then in the last table, we're actually good. It's okay that both 2 and 5 go to 1. That's fine. The key part is that it's still such that 2 only goes to 1 and 5 only goes to 1. It's not the case that 5 goes to 2 different things. Our x values are not repeated. So our 2 functions are the second table and the third table. Those are good. And really what we were ultimately looking for is repeated x values are a problem. Now you do want to investigate that what they technically could do that would not be a problem is if they listed the point 1, 2 twice. That's redundant, but that's not a problem. So the problem is that not only did the x value repeat, but it went to 2 different numbers. That's a problem here. So this is okay. This is not okay because we had an x value going, the same x value going to 2 different y values. That's a problem. For this next one, go ahead and see if you can pause your video and write the function as a set of ordered pairs, find the domain and range, and then state if it is a function. So the set of ordered pairs would be that we have k going to 8, we have l going to 9, and we also have l going to 10. So our domain in this case would be both k and l. Our range in this case would be 8, 9, and 10. And our problem would be exactly what's already been highlighted here. We have l, the input, going to 2 different outputs. Therefore, it is not a function. The input L has 2 different outputs. Alternatively, you could say there's an element in the domain, in this case L, that goes to 2 different elements in the range, in this case 9 and 10. To also give you this information on a coordinate plane, so go ahead and pause your video and see if you can do the same exercise. So write the set of ordered pairs that is this relation, determine if the domain and range, and then decide if it's a function. So this set in particular has, I'm just going to kind of list them. We have the ordered pair -4, -8. We have the ordered pair -5, 6. We have the ordered pair 2, 0. We have the ordered pair 4, 3. And we have the ordered pair 6, -3. So our domain, remember, is going to be all of our x values, all of our inputs. So that would be, I'm going to list it from smallest to biggest. That would be, oh, I actually listed one of these backwards. Which one did I list backwards? This one over my actual very first one. And actually, that looks like that's actually only -7 over. So it would be -7, -4. My bad there. So our domain would be -7, -5, 2, 4, and 6. My range, if I'm listing from smallest to largest, would be -4, -3, 0. Oh my gosh, I made the mistake. No, I didn't. I thought I made the mistake twice. Yep, no, we're good. So we've got -4, -3, 0, 3, and 6. So those are all the elements of the range. And if we were to sort of list out domain to range here, we have -7 going to negative 4. We have negative 5 going to positive 6. We have 2 going to 0. We have 4 going to 3. We have positive 6 going to negative 3. All of that is all good. We do not have a single element of the domain that's assigned to more than one element of the range. So yes, this is a function. This is, I don't know how to spell today, is a function. Each element of the domain goes to a unique element of the range. Notice actually a quick way I could have visually checked that is basically trying to see if for any of these x values they ended up crossing more than one y value, because that would have been a problem. And that actually takes us into the vertical line test. If you have a non-discrete function, something that's like a nice, beautiful, continuous curve, you don't want to be individually checking each and every point. So what you can do more quickly instead is what's called the vertical line test, where you essentially envision if I were to draw a vertical line absolutely everywhere on this guy, would he cross the function only once? If the answer to that question is true, great, he's a function. If that answer to the question is false, where in this case we cross twice for one of the x values, and as long as it's true for one of those x values, we're already in trouble, then it'll be not a function. So go ahead and pause your video and see if you can determine which of these are functions versus which ones are not. So here, this first one, he's going to pass the vertical line test. He is a function. Similarly, this next one, he's still going to pass the vertical line test. He is a function. However, this next one, this circle, he's going to flunk the vertical line test because he crosses twice. So that would be not a function. You can also determine the domain and range graphically for a function. So the domain, remember, is the full set of x values. So you essentially want to have tunnel vision and envision, okay, going from left to right, what are the x values this hits? And here it looks like for his domain, we're doing all x values that are greater than or equal to negative 5, because we have this arrow down here that says he keeps on going forever to the right. The way we would write that in interval notation is bracket negative 5, because we have a closed circle, which means the negative 5 is included, all the way up to infinity with a parenthesis, because philosophically we can never reach infinity. Similarly, for the range, we try to see what's going on up and down. And here, for the y's, it looks like we start at positive 5 and then go forever negative in that negative y direction. So for the range, it's all y's that are smaller than or equal to 5, which in terms of interval notation means we go forever towards negative infinity with a parenthesis because we can philosophically never reach infinity, all the way up to positive 5, and that positive 5 has a bracket because we do actually hit positive 5. Go ahead and see if you can do a similar process for this next function that is listed right beside it. If we're going to look at the domain, we're looking at left and right, and since there's a double arrow situation going on here, that means it goes forever to the right, forever to the left, so its domain would actually be all real numbers, sometimes stylized with this funny r, and an interval notation would be negative infinity to infinity. While for the range, if we're going to have tunnel vision up and down, it goes forever in the positive direction, but then stops when it hits that x-axis. And what is the y value on that x-axis that happens at this point? Y is equal to 0 at that point. So for the range, it is all y values strictly bigger than or equal to 0. And then in terms of its interval notation, that would mean that we use a bracket on the 0, comma infinity with a parenthesis on the infinity because we go forever in the positive infinity direction in terms of what's going on up and down. but we stop when we hit 0 in terms of what's going on up and down. For both of these, we can also envision the vertical line test, and both of them appear to pass the vertical line test. And I'm just going to erase those vertical lines for now, just so that it doesn't get confused with the domain and range later. But everywhere that I could draw a vertical line on both of these guys, it would be only crossing the function once, so we would be okay. Both of these guys would be considered a function, and it's okay to justify by saying that it passes the vertical line test. Go ahead and pause your video and see if you can talk about these next two functions. So for this next function, left and right, we approach but do not hit -3, and then we go all the way until +1, and we actually do hit +1 in terms of what's going on left and right. So its domain would be considered -3 all the way up to 1, but you would use a parenthesis on the 3 because of the -3 because of the open circle at that point. That means it approaches but does not touch that point. While you would use a bracket on the +1 because we actually do touch that point thanks to its closed circle. Another way to state this would be that x is in between -3 and 1. It is strictly such that -3 is smaller than x, aka x is larger than -3. But it's less than or equal to 1 because x actually can hit 1 itself. For the range, now we want tunnel vision up and down. So up and down wise, it actually does hit the point y is 0 right here. So even though it's got an open circle on the other point where y is 0, the fact there is a closed circle once at y is 0 means it actually does hit that point. And then it goes all the way down to -4, and it similarly actually also hits that point. So in terms of what's going on up and down, the y values range from -4 to 0. We still, by convention, list the smaller value first, so in terms of the y's, whatever is more downward, then the larger value second, so in terms of the y's, whatever is more upward. And both of these would have brackets because it actually does hit both of those points. Or you could list this as -4 is less than or equal to y, which is less than or equal to 0, and that would work as well. To determine if it's a function, you again want to picture the vertical line test, and here it does look like this guy would pass the vertical line test because it only hits each vertical line once. So yes, it is a function. It does pass the vertical line test. Let's go ahead and try this next one as well. So again, domain and range and whether or not he is a function. So here, in terms of the domain, I'm going to try to use the same color as last time. So for domain, you want to be looking strictly left and right. So he starts at -4. There are no smaller x values that are hit. And then he keeps going forever to the right. So for the domain, it would be all x values larger than or equal to -4, aka -4 all the way to +infinity. We would use a bracket on the -4 because he is included, and a parenthesis on the infinity because infinity is philosophically never included. For the range, he starts here at that same point, but in terms of the y values, that's 0. So if I have tunnel vision going up and down, that starts at y equals 0, and then goes forever up because of this arrow over here. That means it's going forever in the positive direction up. So for the range, that would be y is greater than or equal to 0 because that's what's going on up and down. I don't care about left and right anymore. And then in terms of interval notation, that would be 0 to infinity with a bracket on the 0 because he is included and a parenthesis on the infinity because we philosophically can never reach infinity. And for him as well, he also is a function because he does pass the vertical line test. Now go ahead and try to picture what would be something that's not a function and what would that look like on the coordinate plane. You could have had many different pictures in your head. You could have thought of something that was more of a sideways looking parabola because that would flunk the vertical line test. You could have thought of something that was maybe some sort of ellipse. That would flunk the vertical line test. Heck, you could have thought of a smiley face, and that would flunk the vertical line test. Anytime you have it where if I were to draw a vertical line through my function, it crosses more than once, that's going to make it not a function. So all of these are not a function because they would flunk the vertical line test. And that's the visual way to check if something's a function. The way that you check with a discrete set of points is you want to check that each x only goes to one y. A quick way to be able to check that is if the x value is ever repeated in your list of points, it's probably not a function. The only way that it would possibly still be a function is if the entire point was repeated. So they listed an x value twice that was still going to the same y value. Unless they do that, chances are they're not. If there's a repeated x value, that probably means that x value is going to two different y values, which will mean that it is not a function. And a way to check that visually is to check if it passes the vertical line test. Passing the vertical line test means if you were to write a vertical line absolutely everywhere going through this function, it should only touch the function once. As soon as it touches the function twice, you're in trouble. It's not a function. And whenever it comes to writing domain and range, domain is your full set of x values. So if you have a nice, beautiful continuous function, you want to have tunnel vision looking at what's going on left and right. Range is your full set of y values. So if you're looking at a nice, beautiful continuous function, you want to have tunnel vision looking at what's going on up and down.